Good evening, everyone. It's a pleasure to welcome you all to Deep Talk 2.0, a brand new season of engaging discussions on cutting-edge innovations in disaster management and sustainability. We are kicking off this season with an exciting and groundbreaking topic: neocarbon's breakthrough, fighting climate change by turning CO2 into concrete. Our speaker, Akhila, will introduce us to neocarbon's innovative approach to carbon capture and utilization. By transforming CO2 into concrete, this breakthrough technology not only reduces carbon emissions but also contributes to sustainable construction. Akhila will walk us through how this process works, its potential impact on climate action, and its role in disaster resilient infrastructure. After the presentation, we will open the floor for questions. So be ready to engage in a thought-provoking discussion. Without further ado, let's welcome Akhila to the stage.
Good evening, everyone. So today, let me introduce this topic by asking a question. Imagine if I told you that the carbon dioxide that is present in the air, we could just capture it and turn it into the buildings we live and work in. Do you think that's humanly possible? But I would say this is possible. We are at the brink of a revolution. This is not science fiction that we are talking about here. This is actually a reality. Now I'm talking about a technology that captures carbon dioxide directly from the atmosphere and transfers it into concrete. So we are actually reversing the climate change. We have heard about reducing emissions, reducing the carbon dioxide present in the air through many methods, by using renewable energy, all of that. But now we are talking about a technology that is reversing the climate change by actually capturing the carbon dioxide directly from the air and converting it into concrete. So, Neocarbon, along with in partnership with another company called Carbonate, has made this groundbreaking technology possible. So first, let us discuss something about concrete. We know that pretty much everything we see around is built of concrete. Whether the buildings, sidewalks, skyscrapers, everything is built out of concrete. But we should also acknowledge that 8% of the global emissions, carbon dioxide emissions, come out of concrete. What if concrete wasn't part of the problem? What if I say it's part of a solution? So, this is the technology that has made it possible. Neocarbon has made a technology called direct air capture. That is the DAC technology. It captures carbon dioxide directly from the air. From the slide, you can say that you can see so many fans. So these fans absorb the air, directly capture. This is how the carbon dioxide is captured, by absorbing the carbon dioxide directly from the air. Direct air capture technology is a technology that pulls carbon dioxide directly from the atmosphere using the specialized machines that we saw. So how does this happen? So the large fans that you saw, they pull the air from the environment, and this air passes through a special filter or a chemical solution. This filter traps the carbon dioxide that is present in the air, and the rest of the gases, that is the air, all other gases would be released back to the atmosphere, but the carbon dioxide will be trapped in that filter or solution. And other gases like oxygen and nitrogen, everything will be passed back to the atmosphere. And this filter can be a liquid solvent, usually amine based or caustic, and in most common cases it is sodium hydroxide. The sodium hydroxide reacts with the carbon dioxide and it precipitates as a stable sodium carbonate. This carbonate is heated at a temperature of 100 degrees Celsius, and a pure gaseous carbon dioxide stream is evolved. So this is the technology. This fan absorbs the atmospheric gases and traps the carbon dioxide. You can see the filter down there. This filter traps the carbon dioxide, and that carbon dioxide is reacted and it forms a stable sodium carbonate, and this is heated to produce a pure gaseous carbon dioxide. So this filter or the solution becomes saturated with the carbon dioxide over time, and as I said, by applying heat, the pure carbon released from that filter. So next is the storing of the carbon dioxide. This captured carbon dioxide from the air can be stored underground, or it can be used in many other ways. So let's discuss about the Neocarbon's DAC technology. So how does it heat this filter? It uses the waste heat. We know that many industries release heat from the exhaust, so that is known as the waste heat. So that waste heat is of high temperature, and that heat is utilized to heat up that filter. So this captured carbon dioxide is used in a process called carbon curing to create strong concrete. Next is carbonates role. The Neocarbon's DAC machines pull in air and trap the carbon dioxide. Then it is sent to concrete production facilities. So the carbonates role in this process is specializing in carbon mineralization. So we said that the Neocarbon captures the carbon dioxide from the atmosphere, and it can store and send it to other concrete production facilities. And what this carbonate does is it does the carbon mineralization, that is converting this carbon dioxide into concrete. So while the Neocarbon focuses on capturing the carbon dioxide from the air using direct air capture, carbonate ensures that this captured carbon dioxide is permanently stored within the concrete through a process called carbon curing. So what is carbon curing? So let us understand how this gas is converted into concrete. So it is done through a process called carbon curing. So the carbon dioxide is injected into fresh concrete, forming a solid calcium carbonate. So the carbonate injects the captured carbon dioxide into fresh concrete, and the carbon dioxide reacts with calcium compounds, forming stable calcium carbonate, which strengthens the concrete. This calcium carbonate adds more strength to the concrete. Therefore, this helps in emission reduction. By integrating, we are actually capturing carbon dioxide from the air and embedding it to the concrete. So we are actually reducing the amount of carbon dioxide that is present in the air. In this way, we can reduce the emissions. Next is the benefits of carbon curing. First of all, it provides a stronger concrete. This reaction strengthens the concrete, and it reduces the need. It doesn't create fragile cements. It gives it much strength for building huge skyscrapers and all. Next, it reduces carbon emissions. That is, since we are capturing the carbon dioxide that is present in the atmosphere and we are taking it back, it is lowering the carbon emissions also. Next, it helps in faster drying. The carbon curing process speeds up the setting time of concrete also. Then it helps in the building of much more durable infrastructure, and this can be installed anywhere in the world with the right conditions also. So these are the benefits of this technology. So the challenges include, it is quite costly. That is, it costs $1,000 per ton of carbon dioxide, and the goal is to reduce this and keep it at a range of 100 to 150 per ton through technology scaling, to improvements in technology and all. So it is expected to drop at around 100 to 150 per ton with further advancements in the future. Therefore, each cubic meter of concrete, if this technology is utilized properly, each cubic meter of concrete can store around 140 kg of carbon dioxide. The Neocarbon's goal is to capture 62.5 tons of carbon dioxide per year. And the global adoption would sequester millions of tons annually. This way we can reduce the amount of carbon dioxide present in the atmosphere and reduce the climate change impacts also. So the next time you see a building, we can imagine that it might be a building that has been built out of a concrete which has carbon dioxide in it, which has taken carbon dioxide directly from the sky. So therefore we must invest, innovate and scale this technology, and it depends on us how many more buildings we can create this way. Thank you.
Thank you, Akhila, for that insightful presentation on Neocarbon's groundbreaking technology. Your discussion has given us a new perspective on how innovation can turn environmental challenges into sustainable solutions. Now, let's open the floor for questions. Feel free to ask Akhila anything about this technology or share your thoughts on its impact.
Which all countries uses this technology?
So this technology is mainly used by United States, Canada, then the Middle East, Japan.
Akhila, how does Neon Carbon's approach compare to other carbon utilization technologies?
So other carbon technologies methods focus on storing carbon dioxide underground or converting it into fuels and all. But this technology captures the carbon dioxide and it converts it into construction materials like concrete. Any other questions?
Thank you all for your curiosity and active participation. With DTalk 2.0, we aim to explore more transformative ideas that shape the future of disaster resilience and sustainability. Stay tuned for more inspiring discussions and have a great evening. Thank you.